And welcome to the Daily Space Weather, everybody, and happy Thanksgiving. Looking at the sun in 131 angstroms. We do see a little bit of a coronal mass ejection kicking off. We'll show you in a minute. First, let's zoom in on this active region rising just on the east, barely north of the equator. Not a sunspot, looks like some cycle 24 activity right here underneath my pointer. No umbral fields associated with that. There's the North Pole region. There's the South Pole region. Here's a 171 angstroms view. And again, we did have some ejecta come out of the eastern limb of the sun here. Let's take a look at that. And you can see right around noon yesterday, you see a small coronal mass ejection set to miss the Earth to the east. Here's a view from the LASCO C3, and you see a little bit of ejecta coming out of the left side right there. Again, coronal mass ejection expected to miss the Earth to the east. Let's look at some more data here. And again, happy Thanksgiving, viewers. Let's talk about Robitaille's paper, 40 Lines of Evidence Against the Gaseous Model of the Sun. Let me give a quote. "The earthly lines of evidence may be the most powerful. They are certainly the most far-reaching. Climate dictates our future and the survival of humanity. Thus, it is fitting to close the discussion with the climactic line of evidence. This acts to highlight that there is much more to studying the sun than intellectual curiosity. As such, the young sun problem and the great Maunder minimum of the Middle Ages are briefly discussed." So read the paper. Again, it's called 40 Lines of Evidence for Condensed Matter, the Sun on Trial Liquid Metallic Hydrogen as a Solar Building Block by Pierre-Marie Robitaille. We've left links below the video. And also check out his YouTube page, Sky Scholar. And we're going to link to one of his videos here. And this time it's going to be the NASA Parker Solar Probe explained. Let me play a little clip. As the Parker Solar Probe is one of the most important objects to studying the sun, it's also the fastest object ever built by mankind. Let me just play a little clip here.
Integrated science investigation will monitor energetic electrons, protons, and heavy ions. Third, the wide field...
Anyway, the Parker Solar Probe, currently in process. We're still waiting to see some data from that. Anyway, links to that. Are you aware that the sun looks like this from the North Pole? If you're looking down at the sun from the North Pole, this is what it looks like. The Proba 2 repeatedly flew over the North Pole of the sun right through its Z fields in order to get these composite images. We've linked to that as well as to this article here, the solar polar images of the sun. Now, most people are not aware that that's what the sun looks like from the north, as it looks kind of weird. Keep in mind this has the corona cropped out, as it would look even cooler if we had that, but since the sun is kind of large, this craft was only able to take small strips of images at a time and then had to stitch them all together to create this GIF animation. Again, we linked it below the video. Let's go back to some data here, like the X-ray flux, which is totally flatlined on your US Thanksgiving. Solar wind. In real time, we're looking at a 302-degree phi angle. Solar wind density 5.1 protons per cubic centimeter. Solar wind speed has ramped down again for a 24-hour period to 328 as solar minimum conditions persist. There's the data from the ACE craft. And we did see a small density spike right here. We won't get into it. Here's the geospace magnetosphere movie, and it's looking pretty homogeneous out there. in the earthly double layers. Let's just let that play through. We see a small increase in the density on the magnetotail side, and the magnetosphere is quite offset as we approach winter in the northern hemisphere. This 4 hours of data brought to you courtesy University of Michigan Geospace Model V1.5. I assume the geology department, or perhaps the physics department. Who knows? Here's some more of their model. Delta B, changes in the Earth's B field. And we don't see very many, although over the northern polar region here, we see mainly perturbations over the Canadian North Pole, not over the Siberian North Pole, and a little bit of evidence of the South Pole drifting into the southern Indian Ocean. 10.7 centimeter radio flux, a measurement of the radio output of the sun's outer corona, up to 72, just on or above that orange line we've drawn in at 70 solar flux units. For you new viewers, the 10.7 centimeter radio flux is quite similar to sunspot number. This was discovered in 1947 with some basic radio equipment, and somebody figured out that we can figure out solar cycles even if it's cloudy, as it's impossible to measure sunspots from the Earth. If it's too cloudy, you can't see through the clouds, although now we've got a lot of space telescopes, so that's a good thing. GOES magnetometer is looking fairly smooth here, as we still appear to be solidly in the South Pole oriented portion of the heliospheric current sheet. And you can see that noted here in red. That's the South Pole oriented polarity. North Pole oriented polarity shown in green. And expecting that active region rising on the east to actually contribute to the South Pole remaining in charge of the current sheet. Anyway, there's the last image. Nothing to write home about there. KP index is at 1, and we're skipping cosmic rays today, although we did leave a link to this website below the video in the description. So check that out. Monitor cosmic rays yourself. There's the GOES electron flux. Actually looking surprisingly low. Looks like we're getting into a little bit of an electron deficit here, at least on the non-relativistic electrons. These are the lower energy between less than or equal to 2 or greater than 0.8 mega electron volts. The relativistic electrons have peaked just below 1e plus 10, plus 8. So it did peak out at moderately high levels there, and probably expecting this to drop, as we're not expecting any coronal hole wind streams or any ejecta to be striking the magnetosphere anytime soon. Here's the ionosphere, and we still do see charge-up anomalies over the South Pacific. It's a little bit more charged than you would expect it to be at nighttime over there. And there you can see a charge-up just southeast of Hawaii. We've been seeing that for about a week in the ionosphere. And let's move on to more data. Now, I did notice something. Apparent magmatic motions, as we saw some seismicity here on the big island of Hawaii, as this earthquake actually happened at 2,800 meters above the surface. In other words, about halfway up the slopes of Mauna Loa. Otherwise, not a lot going on seismically speaking. Largest earthquake of the past 24 was a 5.6. Actually, there were 2 of them. There was one at Fiji, which was extremely deep at 570 kilometers, as well as a 5.6 in the Scotia Sea, just north of that peninsula on Antarctica. Aftershocks in Albania. I'll just scroll up the list of the last 24 for you, as we're trying to shorten the videos and not read up all of the earthquakes over a 4 magnitude. A couple of deep quakes there. There's a 4.7 deep quake in Russia. There's that 4.5 at Fiji at 578 kilometers. Again, no 6+ magnitude quakes over the past 24. Let's look at the pressure maps here as we mix up the value-added services. And there's the pressure maps courtesy windy.com. Here's me drinking some coffee, complete with coconut oil, cocoa powder, cayenne pepper, nutmeg, and cinnamon. It's like taking a vitamin in the morning. In fact, it is taking a vitamin in the morning. Some severe weather over the U.S. Snarling transportation around the Thanksgiving holiday. The snow forecast has been moderated big time for where I am, as we were calling for 16 inches as of yesterday, and now we're only calling for like 2 inches. We'll get into it in a minute. Next, before we do the volcano rundown, check out what we noticed yesterday on Sakurajima. Now, this is a Volcano YT, and shout out to Oppenheimer Ranch Project for turning us onto this channel. Check out this insane plasma discharge looking eruption here. Notice the way the incandescent light from the lava looks orange. Watch this, folks. Watch this explosion. Everything turns green. And it happens repeatedly on this video. We've linked it in the description, so you can look at these insane plasma discharges. What is up with that? That is not your average St. Elmo's fire. And here's the volcano rundown. Mount Aso, possible activity. Unknown volcanic ash cloud. Let's just say don't fly over it, period. Sakurajima exploded. Flight level 9,000 there. Sanjiang-api, and we do see some new volcanoes on the list here. Sanjiang-api, flight level 8,000. Tokono, flight level 7,000. Popocatépetl, flight level 19,000. Santiaguito in Guatemala has been exploding. Not exactly sure. Ash plumes 600 to 900 meters. So that's a new one there, not on the list yesterday as far as I remember. Pacaya back to erupting there in Guatemala. Lava flows on the northwestern flank, as well as ejecta to 75 meters above the crater, and some avalanches of material. Fuego back on the list also. Flight level 3,600 there. Revenador exploding. Flight level 15,000. Sabancaya, not sure on that one. And Nevados de Chilean, unsure on that one. So a couple extra volcanoes kicking off as solar activity's weak. By the way, while we're talking about YouTube, we just talked about Volcano YT. Thanks to our new subscribers, viewers, etc. Please don't forget to press like and subscribe if you enjoy the content. Let's move on to more stuff. Here's where stuff is in the solar system. And there's where stuff will be in 7 days. Here's where stuff is above my head. I like to check out in-the-sky.org. It's super good. You can even animate your sky map. I'm interested in stuff like when Deneb will rise. One of the most obvious cosmic ray sources, Deneb, sending protons through your brain, especially if you live in the northern hemisphere, on a regular basis. And welcome to the That's Censored and That's a Sinkhole, where we take a quick moment to talk about human stupidity. Now, let's talk about a stupid guy. See this guy? Well, he's been arrested in Toronto. What for, you ask? Well, Samuel Opoku was arrested for throwing buckets of poop on people in libraries. It happened on 3 separate occasions. He walked in with a hard hat on, looking like a complete idiot, and then he assaulted people by throwing liquefied fecal matter on them. It's a human stupidity story for your viewing pleasure on Thanksgiving. If you see this man outside of jail carrying a bucket, I don't know. Don't punch him in the face. just run away, as a giant 5-gallon bucket of feces is probably pretty heavy. We've been doing a star study every day for the local star group. So we've left links to this Wikipedia article about the nearest stars and brown dwarfs. If you've got red, green 3D glasses, maybe check it out. Don't have a seizure. Today we're going to be talking about EZ Aquarii ABC. It's a trinary system. It's got 3 names. This one is located 11.3 light years away. The close pair in it's a trinary system. The 2 closest stars are extremely close to each other. 0.03 astronomical units, where an astronomical unit is the distance from the Earth to the Sun. So these stars are only 3/100ths of the distance from the Earth to the Sun apart, and they orbit in a 3.8-day orbit. So that's quite a fast orbit. Again, it's a trinary system. The other star is in a 823-day orbit. Not sure about exoplanets on this one, but we did leave links to the article about it if you want to read up on EZ Aquarii A, B, and C. It's also known as Luyten 789-6. Shout out to Gareth about naming conventions of stars. Ouch. And let's talk about some more serious cosmology here. A new theory for how black holes and neutron stars shine bright. Now, this is quite a convoluted article. And what we're talking about here is, why are black holes and neutron stars so bright? Well, it's because material is being accelerated to near light speed around its magnetic fields, as well as electrons sending out synchrotron radiation. And this is part of the reason why we said, hey, electrons don't just hang out by themselves. They don't just rotate around things by themselves. While yes, it's the electrons that are emitting the radiation, they have to be rotating around something like a magnetic field. And in order to have a magnetic field, guess what you have to have? Condensed matter. Now this image here is of the Crab Nebula. And all these supernova remnants, they seem to have a star inside of them, since stars don't collapse and die at all. And all stars are variable. Let me read another quote here. As this is headed in the right direction, we figured out an important connection between turbulence and magnetic reconnection for accelerating particles, but there is still much work to be done. Advances in this field of research are rarely the contribution of a handful of scientists, but a massive collaborative effort. In any case, magnetic reconnection, magnetic field accelerating particles around in, flux ropes, whatever you want to call them, is an advance in cosmology, and for that we thank you. We did leave a link to this phys.org article. Next, let's talk about cosmic acceleration. Please leave a comment if you think galaxies are moving away from each other at an ever-accelerating rate as measured by the Doppler effect of redshift. Please don't make a fool of yourself if you don't understand this stuff, as mainstream cosmologists believe that everything's accelerating and there's this isotropic expansion, meaning it's homogeneous wherever you look in the universe. And this is another important cosmology article here, in that dark energy and dark matter are busted again. Now, every article you read is going to have a different idea here. This one is stating that dark energy supposedly makes up 70% of the universe. Not something that I personally believe. The fact that they have the words non-accelerating universe in this paragraph is fantastic, so I'll read it without vetting it. There are indeed other probes of our expansion history, that is, the imprint of baryon acoustic oscillations in the distribution of galaxies, the ages of the oldest stars, the rate of growth of structure, but still, such data is still too sparse. Presently equally well consistent with a non-accelerating universe. The precisely measured temperature fluctuations in the cosmic microwave background, something that isn't real, are not directly sensitive to dark energy, although its presence is usually inferred from the sum rule that while cosmic microwave background measures the spatial curvature of the universe to be close to zero. In other words, this is part of the flat universe theory, folks. Its matter content does not add up to the critical density to make it so. This is, however, true only under the assumptions of exact homogeneity and isotropy, which are now in question, and that's a good thing. It's another step in the right direction, as cosmic acceleration is not doing what Hubble thought it was doing. And the understanding of redshift is an issue, as it's not strictly caused by the Doppler effect. Things aren't moving as fast as they were calculated to be moving, and they're not necessarily moving away from you at all. Let's leave it there. Anyway, read the article if you understand anything about this, as it's one of the big messes in the field of cosmology. Now, I considered getting a degree in astronomy. I was thinking about doing physics with a minor in stellar cosmology, or just if I could have found a university to actually offer a major in stellar cosmology. But I didn't like the prospects of what I would be doing with a 4-year degree in the field. So, in any case, let's talk about its ARP 293, a pair of galaxies, NGC 6285 and NGC 6286, which appear to be gravitationally bound. Here's an article from SciTech Daily about the close relationship in the Dragon. And it's a great view here, as one is a semi-edge on disk, and the other one is a proper edge on disk. And if you look at a better image like this one here, you can see that there's a massive filament column connecting these two galaxies. And it's another case of perspective shows us the way. Anyway, this Hubble image, it links to a bunch of other Hubble images here. If you want to check that out, we've linked to the SciTech Daily article as well, and also to this better image showing this filament in between these two galaxies. Speaking of galaxies, we need humans to classify them. And check out this merging thing with an artifact in the foreground here. We got a serious galactic merger going on here. Check out Zooniverse.org, the largest citizen science project in the world, and help us classify a few million more galaxies. Let's show you how it's done. This one's got features. It is not an edge on disk. We're going to say there's a weak bar. Again, significant merger here. We do see signs of a spiral arm pattern. They are, we're going to say, loose, as I see 3 spiral arms there at least. And this is a jumble up of 2 galaxies. This area here in the foreground, that's just an artifact, as you're only going to be classifying the internal object. We're going to say a moderate bulge. We're going to say a large bulge. Please leave a comment if that's what she said. Is the galaxy merging or disturbed? Well, it's absolutely merging, as we see really 2 bulges here. And do we see rare features? Well, I see a ring-like feature. I see a lens-like feature. I see irregularity. I see obvious dust lanes, obvious overlap, and something else. It's a pretty good one. Let's save it for posterity. And that's how you do it. Will you be the citizen scientist to classify that galaxy? Who knows? Zooniverse.org's Galaxy Zoo. Check it out. Zooniverse.org. And let's get back to some current data. Here's a lightning map, courtesy lightningmaps.org. Significant thunderstorm off the coast of New Jersey there. Several hundred miles off the coast. Lightningmaps.org, the next time you hear thunder. Check it out, I'll even send you sound waves. Let's zoom in on Texas. Shout out to Dallas and Fort Worth. There is thunder rolling in. I thought there was. Anyway, there's a lightning situation on a global scale. Now, we're located in Lehigh Valley, Pennsylvania, which is right in this little bend here in the Delaware River where New Jersey protrudes into Pennsylvania, right around there. And they've relaxed our snow forecast quite a bit. They were calling for like 14 inches on this same model yesterday. Now we're down to like an inch, maybe 2 inches, while the rest of the country pretty much gets hammered. And it looks like we're going to be spared the snow in this area for quite a while the Rockies and California and the central U.S. just get hit over and over again. Check it out. We have areas in southern Colorado here where it's looking like they're going to have about 4 feet. Let's talk about how hot the planet is. Here's the NOAA multi-sensor snow and ice cover. The northern hemisphere looks kind of snowy, folks. By the way, I don't know if you're aware of how ice ages start. Here's how ice ages start. Snow falls in the wintertime, raising the Earth's albedo, making it even colder, reflecting light and heat back into space. Some of that snow doesn't melt in the summertime. The next winter, it snows more. This is how glaciers form in the real world. And it's not even December yet, folks. Notice the way the snowfall is outside of the 30-year average from 1982 to 2012. And it's getting back into the average now, but in mid-December in mid-November, we were a couple hundred gigatons above normal. And here's the northern hemisphere snow water equivalent well outside of the standard deviation. Apparently the planet is so hot that it's cold, folks. So stop producing all that CO2 before we all burn up and Greta Thunberg has to buy her own yacht. Here's a US Doppler radar map. We've got snow falling in half of the state of New Mexico, the Texas Chimney, the Oklahoma Panhandle, heavy snow falling in Maine. I'm not just going to go naming states, but check out this area in Utah. Man, oh man, the Great Salt Lake is getting hit with a wintry mix. Check it out, it's just stagnating. A perfect example of when to look at the water vapor map, and it looks like it's going to be an extended period of time here. In fact, it's even going to increase as we see some more moisture headed their way. Here's the full-size U.S. water vapor map. And we're going to look at the convergence zone over the Pennsylvania-Ohio border. Check out the ultra-obvious electromagnetic field force lines. By the way, for all you chemtrail enthusiasts, the resolution of these images here is 2 kilometers. So the smallest pixel on your screen there is 2 kilometers. If you think those are chemtrails or contrails, please enroll in a community college physics course. Man, oh man. Check it out. Those parallel lines parallel to the mode of travel of the water vapor. No surprise here. Look up in the sky, folks. It's electric. Here are the extremely meridional jet stream flows of the Western world. Check out that air coming from Alaska straight down the California coast. There's going to be one hell of a low pressure area in British Columbia, and it's going to be stagnant until that thing moves. Let's look at the eastern world. Here are the jets of the east. Things are a little bit more normal on that side of the planet. Let's talk about the mission of our organization. and by the way, there is a smashomash.org. It's to assist, study, and report on the ongoing formation of a unified theory of physics. Welcome to the Neo-Renaissance, as cosmology, physics, and astrophysics are getting rewritten on the daily basis. The mission is also to raise awareness of the general public of the relationship between space weather and Earth effects. Welcome to space. Welcome to Earth. All your weather comes from space. It's also to connect and to consult with media organizations to multiply our reach, hence videos like this one. Also to demonstrate cutting-edge proof-of-concept solutions to problems, such as growing tomatoes indoors over the winter. And our tomatoes are already flowering, even though it's well beyond the first freeze outside. To publish scientific papers in a multidisciplinary manner, including but not limited to spectroscopy, chemistry, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc. Also to assist mankind by advancing the study of predictive phenomenon, to do things like optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And last but not least, what everybody in science ought to be doing is not being ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion. Sometimes it takes a while for this stuff to sink in, folks, so be patient with people. And thanks, patrons. If you'd like to support our mission, please do so at patreon.com/smashomash, the real source of funding for this channel. And thanks again, patrons, for being associate producers of these videos. Thanks, Smash Team, and everybody else who views on whatever location. And stay tuned for a bonus feature. It's about 10 hours of the local yellow dwarf in 304 angstroms. I apologize for the flashing, as there's a little bit of missing data there on the SDO feed, as well as slow data loads. Anyway, there's the South Pole region. Here's the North Pole region. Thanks again for tuning in, everybody. Please don't forget to press like and subscribe. Press the notification bell. Thanks, everybody who tunes into the live premieres. We really appreciate that. Enjoy your Thanksgiving, Americans. And let us know what's on your menu today. We'll post something in the comments. Stare at the sun. When you do so, don't drink it. If you drink, don't drive. And since it'll never be Thanksgiving again, happy Thanksgiving, and may the solar wind be at your back, and that atherosclerosis absent from your veins.